3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at why NASA picked the moon's south pole as the perfect location for future Artemis missions. Each day we get closer and closer to returning humans to the surface of the moon. NASA is working hard on SLS, new spacesuits, and general plans surrounding the upcoming Artemis missions. With the first official mission expected to happen in late 2024 to 2025, it's coming a lot sooner than expected. However, the moon is still a large mass with many different possible locations to set up a base. NASA has decided the south polar region of the moon is the best location for future missions. This location features many different benefits, including access to persistently illuminated areas, resources, and more. All of which are important factors when trying to set up a more permanent human presence on a different celestial body. While the moon is a very barren and unforgiving place, some areas are more promising than others. After a lot of time and research, NASA is confident in the future location of Artemis missions. Here humans will construct and install infrastructure that helps us not only learn more about the moon, Earth, and more, but also prepare us for future missions to Mars and beyond. Looking back at some of the historic Apollo missions, one of the major downsides of the technology available was the lack of options when landing. Due to a number of factors, they were limited to practically the same orbit around the moon, which meant a large portion of the celestial body was impossible to explore. Artemis, however, will have the benefit of choosing between practically any specific spot across the entire moon. This means that based on extensive research and testing from past missions, satellites, and more, NASA can choose the best location for future Artemis missions. The strategic emphasis of the Artemis program is to use the moon as a proving ground for technologies and processes that will provide greater independence from Earth. In addition, the intent is to achieve this through extraterrestrial operations, such as manufacturing and mining, as well as conducting cutting-edge lunar science, all of which will enable America and its international partners to mount historic human missions to other destinations and promote the creation of a thriving cislunar economy. These are important considerations prior to learning the reasons for NASA's choice. After a lot of thought and consideration, the agency is very confident in a specific area of the moon. A successful this spot on the moon will help create and hold a future base and human presence. Specifically, the selection of the moon's south polar region, defined here as the area within 6 degrees of latitude from the lunar south pole, as the location for the Artemis 3 landing site, and the subsequent Artemis base camp, reflects an emphasis on executing a sustained program of lunar exploration, with ample opportunities for commercial growth and international participation. This approach provides significant benefits in many different ways. Here I will highlight some of the major benefits of the south polar region of the moon, and why exactly NASA picked this specific spot out of all the options. The first important factor has to do with having access to persistently illuminated areas of the moon. Light, as you can imagine, is an extremely important resource for day-to-day life. This applies to us on Earth and even more so to astronauts on the moon. However, the moon is different from Earth in a lot of ways. While a day on Earth is 24 hours, a moon day is just over 700 hours. This, along with a host of other differences, add to the challenge of putting humans on the surface and having them stay there for an extended amount of time. When on the moon, the light will likely play a key role in not only physical and psychological impacts on the astronauts, but help power and keep the base running. Taking a closer look at the south polar region, the physiographic characteristics such as slopes, crater density, and roughness are not substantially different from other regions on the moon. However, the very low sun angles encountered in the polar regions have the effect of producing areas that are illuminated over most of a terrestrial year. Areas have been identified on the lunar surface that are illuminated for over 200 days a year. Areas like these are few, but offer clear operational benefits, including a more favorable temperature regime, reduced duration of lunar nights, and persistent availability of solar power, to name a few. These benefits offer pathways to earlier, more capable missions and extended duration operations on the lunar surface. The next benefit of this specific region of the moon has to do with available resources. NASA explains this as potential access to surface-accessible volatile deposits that can be leveraged for large-scale resource utilization. As we know, NASA not only wants to return humans, but set up a more permanent human presence. This involves a lot of crucial infrastructure to keep humans alive and safe each and every day. Unfortunately, while rocket technology continues to improve and get cheaper, it still costs a fortune to get resources on Earth all the way to the moon. This means that anything or any resource on the surface of the moon is practically invaluable to NASA. Rather than transport it hundreds of thousands of miles, they can use what little resources the moon provides. The topography at the polar regions that produces areas of near-permanent illumination also effectively blocks most of the sunlight at very low sun angles in some areas. These areas of constant or nearly constant darkness in permanently shadowed regions can trap and collect various volatile species. NASA points out that the potential existence of accessible resources, such as hydrogen and oxygen, that can be straightforwardly leveraged, represents an intriguing opportunity to live off of the land. In addition, when the grade and tonnage of these volatile deposits are characterized, a cislunar economy could result, providing significant cost reductions for lunar surface logistics and resupply efforts. Transporting hydrogen and oxygen harvested from the lunar poles to cislunar space would also be enabling for ambitious human expeditions to other destinations, as well as other activities throughout cislunar space. These two clear operational benefits of persistent illumination and access to potential resources have led to the selection of the Moon's south polar region as the location of the Artemis 3 mission and the subsequent Artemis base camp. Not to mention the large list of additional benefits from this location related to science experiments and much more. Conclusion. It has been around 50 years since a human stepped foot on the Moon. Since then, technology has changed immensely, and the opportunities from returning to the Moon are endless. However, with the option to land practically anywhere on the Moon, it brings up a difficult decision of where exactly a future Artemis base camp should be. After a lot of thought and consideration, NASA has decided that the south polar region of the Moon is the best location for future Artemis missions. This has to do with its consistent access to light, resources, and more, all of which will play an invaluable role in future development on the surface of the Moon. We will have to wait and see how Artemis progress continues and the impact it has on the space industry. Thank you very much for watching.